Ever pondered about the activation function used in a radial basis function network? Today, we're going to delve into this intriguing topic. In the intricate world of neural networks, there exists a unique type of network known as a radial basis function, or RBF network for short. RBF networks are a breed apart, characterized by the use of radial basis functions as activation functions. The most commonly used among these is the Gaussian function. Output. The defining feature of the radial basis function is its reliance on the distance between the input vector and a prototype vector, often referred to as the center. The distance we're talking about here is not your everyday physical distance from point A to point B, but a measure of how different the input vector is from the center. This function churns out a value that either decreases or increases with distance from the center. The highest value occurs when the input and the center are identical. Imagine a pebble dropped in a calm pond. The ripples are most pronounced at the point of impact, and they diminish as they move away from the center. Now, you might wonder, why use a radial basis function like the Gaussian? The answer lies in its ability to perform a form of interpolation in the multi-dimensional input space. What this means is that the RBF network acts as a soft selector or detector for features that closely resemble the prototypes represented by the centers. This unique property equips RBF networks with the capability to model complex, non-linear relationships in the data. This makes them especially useful for tasks that require pattern recognition and function approximation. In summary, the radial basis function acts as the linchpin that holds together the RBF network. It's a function that relies on the distance between the input vector and a prototype vector, with the most common type being the Gaussian function. Its ability to perform interpolation in the multidimensional input space enables RBF networks to model complex, nonlinear relationships, making them a powerful tool for tasks like pattern recognition and function approximation. So next time you come across a complex, nonlinear problem, remember the radial basis function network and its unique activation function, because understanding how things work is the first step towards mastery. And who knows, this could be the key to unlocking the next big breakthrough in machine learning. Bye.